Hi everyone, this is Team Oxidizers, and the project that we chose to port was the C implementation of the lz4 compression algorithm. And the target language for this port was Rust. Now, the goal was not just to make it compile, it was to prove that the Rust port behaves exactly like the original C implementation. And to ensure that this happens, the proof strategy we followed was ABI compatibility. So the crate actually exports the same 141C symbols as libLZ4. Like if you notice here, we have included the original project as a Git submodule, and we actually run the tests on the original project directly against our C port, against our Rust port without any modifications. So to prove this, we have included a make target called kickoff verify, which basically compares the hashes of the upstream tests with the hashes stored during kickoff. After this, we can also check for the ABI compatibility. So if I do make ABI check, it basically compiles the Rust port and checks if it exports the same 141 symbols that are expected in the original C version. Then we can run the original unmodified upstream test suite directly against our port with the make test target. Now, because the upstream CLI remains in C but links to the Rust library, even the original shell-based end-to-end tests exercise this port. So we'll just wait for it to finish. So as we can see, all of the original tests have finished execution and we have 100% test parity. Now the next test is actually one of the most strongest checks in our project. So the thing is, the upstream suite which we just ran right now, it mostly checks round trips. So basically you take a file, you compress it, you decompress it, and the test just compares the decompressed file with the original file, essentially a round trip. It does not actually compare the byte identity of the compressed file itself. So the problem with this is that it can miss wrong yet valid compressed output. And so make diff test is a target that basically runs a few tests that we have written to compare this compressed output for byte identity. So this will go ahead, compress a bunch of files, and it'll compress files in both the Rust port as well as the original C library, and then compare them to check if they are identical at the byte level. So as we can see, it has finished running and it has noted that 1369 files were registered as byte identical. Now just to mention 3 important engineering decisions that make this work. So the first is that we confine all of the unsafe calls to the ffi.rs file. The implementation modules themselves completely forbid the usage of unsafe code. Second, as I just said, we preserved byte identical behavior instead of improving the algorithm. This is what the diff test is for. Third, we only ported the library, not the CLI. That kept the project under the hackathon's line count ceiling while still letting the original command line tests exercise the Rust code. Now we also have a differential fuzz log, which is what diff test actually uses under the hood, and a single command benchmarker that can compare both the C and the Rust port and produce a machine readable JSON complete with statistics like throughput, RSS, binary size, startup time, etc. So the claim is same API, original tests untouched with 100% parity, differential checks for byte identity and malformed inputs against the pinned C implementation. That is lz4-oxide. Thank you.